Hello everyone, very good morning and welcome to the Byjus exam prep. How are you guys? It is a BARC series. Okay, there is some 1 minute. Is it audible? In this session we are going to discuss some important questions from analog circuit that is related to what BARC 2024, and you can revise analog. As you know, this is very important subject for this competitive exam. Okay, so I am going to discuss some important numericals. Then first of all, this is my introduction. Myself Sanjay Rathi, 23 years of teaching experience. These are my ranks in engineering services exam and I have trained more than 1 lakh students for these competitive exams. Okay, अब last moment पे कुछ questions revise कर लीजिए. Right, as you know, this subject is important. तो कौन कौन से क्वेश्चन आ सकते हैं, किनकी प्रोबेबिलिटी ज्यादा है, कौन कौन से टॉपिक्स इंपॉर्टेंट हैं, हम लोग डिस्कस करने वाले हैं यहाँ पर. Then guys, this is my telegram channel where I will upload my PDF, that is electronics by Sanjay Rathi. You can join this if you want the PDF of this session as well as previous session. Then yes, you can join. And for daily dose to improve the concept, for daily important questions, and if you want to get the information about any competitive exams, then you can join here. Then guys, this is a very important opportunity for you. National Scholarship Test, get up to 90% off on our program, that is on 10th of March. And window will be open from 9 a.m. to 9 p.m. Please note the time and take a step towards success in GATE. You can register now for this. Install Byjus exam prep app. And then there is one important workshop by Dheeraj Sardana sir, 7:30 p.m. Step-by-step guidance to GATE 2025 in first attempt. If you want to know about the GATE exam, then that is the workshop for you guys. Okay, so you can join, you can register here for this. Link is given in description. The first question, what is the answer for this one? Yes, please everyone tell me what is the answer for this question. We are going to discuss some important questions from analog guys for BARC 2024. Tell me what will be the answer for this question. जल्दी से बताइए जरा. Voltage follower circuit are used in active filter, sample and hold circuit, bridge circuit with transducer, all of the above. What is the voltage follower and what are the applications of the voltage follower? So quickly, I'm going to give you the idea about the voltage follower. This is the voltage follower. Here we are giving the input and there is a negative feedback. Ideally the feedback factor is 1 because Vf is equal to V0, right? And the voltage gain, closed loop gain, is nearly equal to 1, right? Input resistance is very high, output resistance is very low. And what are the applications of the voltage follower? It is used in active filter, yes. Butterworth filter, first order Butterworth filter. For example, if you are going to apply the C and R here, this is the first order Butterworth filter, high pass filter. It is used in active filter. Yes, it is used in sample and hold circuit. Bridge circuit with the transducer, yes. And then finally all of the above means what is the answer for this question? D. D for Delhi. These are the applications of voltage follower. तो आपके कमेंट्स मुझे आ जाइए आप. Is it clear everyone? This is clear to you guys? Okay then. So this is a voltage follower. Remember guys, in this case the feedback mechanism is voltage series feedback. Input resistance very high, output resistance very low, and the gain is nearly equal to what? 1, and that is the case of voltage series feedback. It is a special case of non-inverting operational amplifier. Okay. Then second question. Consider a Zener voltage regulator, right? Voltage regulator is again another very important topic for all competitive exams. तो क्या आएगा क्वेश्चन? देखो भाई, आपको डायग्राम नहीं दिया हुआ है, जल्दी से आपको डायग्राम बनाना है. Consider a Zener shunt regulator that contains a fixed resistance Rs as a series element. The input voltage varies between 10 to 25 volt. if the maximum allowable Zener current for a 5 volt Zener used is 0.1, this is what is the maximum allowable Zener current, then the minimum value of the load resistance that can be used, what is the minimum value of the load resistance that can be used, guys? Okay, so what is given? Maximum allowable Zener diode current. If the maximum allowable Zener diode current is given, then you can calculate the PZ, power dissipation. What is the maximum power dissipation? Voltage IZ max. IZ max, that is the power dissipation. Now, so you can get, this is the rating of the Zener diode. What is the rating of the Zener diode? 5 into 0.1. 5 into 0.1, that is the 0.5 watt or 500 milliwatt. That is the rating of the Zener diode. This is the maximum power dissipation across the Zener diode allowable. Because what is the current given? 0.1. Then what is asked here? But what is the asked here? Minimum value of the load resistance. So remember, only we have the two formula for the Zener diode. Just I'm going to solve this. Okay. This is the Zener diode. Shunt voltage regulator. And that is the load here. Variable load. This is the Zener diode. This is the RS. This is the VS. Okay. Now what is the variation here? Variation in the input is maximum to minimum 10 to 25. 10 to 25 volt. What is the value of the series resistance given? Series element RS. Quickly you can solve this, right? So RS has a series resistance. The input voltage varies between 10 to 20. If the maximum allowable Zener current for 5 volt is 0.1, the minimum value of the load current that can be used is. Okay. Now, in a very simple case, you can use, there are two formula. This is the I. This is called IZ and that is called what? IL. Okay. So what is the IZ? You can write I minus IL. Right. Now there are two formula. What is the IZ minimum? IZ minimum is I minimum minus IL maximum. That should be greater than or equal to knee current. But knee current is not given in the question. Then IZ minimum will become I minimum. Y minimum is what? VI minimum minus VZ upon RS minus IL maximum. What is the IL maximum? V naught upon RL. RL minimum. That should be greater than or equal to IZK. That should be greater than or equal to IZK. But what is the RL minimum is required? Yes, then the minimum value of load resistance is required. So from this equation you can find the RL. So what is the V naught? V naught is nothing but VZ. V naught is nothing but VZ. And it is not given in the question, but you can take 1 kilo ohm, otherwise they will give you the answer in that. Okay, 1 kilo ohm for example. Now you can put this value here. What is the VI minimum? Minimum is 10 minus VZ. What is the VZ given? 5. Now you can solve this. Calculation is your part. Upon 1 minus V naught. V naught is VZ, that is the 5 upon RL minimum, that is required here. That should be greater than or equal to IZK. If the IZK minimum Zener diode current is not given, you can take it what? 0. You can take it what? 0. Then it will become 5 minus 5 RL minimum. That should be greater than or equal to 0. 5 is equal to, it should be greater than or equal to 5 upon RL minimum. What is the RL minimum? It should be greater than or equal to 5 by 5, that is 1 kilo ohm. In this way you can solve this. So if the value of the RS is given, then you can easily solve. In this question, just I have assumed the value of what? RS, value of RS, guys. Okay. So this is the, just remember that is the solution for this question. This is the solution for this question. That is a very, very important formula, how we can find the RL minimum from this. Okay. Then, any doubt? One minute. कोई भी डाउट है तो पूछिए भाई. चलिए नेक्स्ट क्वेश्चन. What is the answer for this one? Try to solve this question. ओके देन. अच्छा चलिए आते हैं आप जरा. Now, a differential amplifier shown below has a differential gain of 100 and a CMRR of 40 dB. If V1 is 0.6 volt and V2 is 0.4 volt, calculate the output voltage. कोई भी differential amplifier है, okay? अब आप देखिए जरा. There are two voltages V1 and V2, non-inverting and inverting voltage. It is given, and that is the output. Differential gain of 100 and CMRR of 40 dB. CMRR, that is called common mode rejection ratio. So CMRR means what? AD by AC. AD by AC. So AD is given as 100 and CMRR is given as 40 dB. When the CMRR is given with 40 dB means 20 log of AD by AC. AD by AC in dB. Now you can find the AD by AC. AD by AC, that is nothing but 100. Take the log inverse, that is the anti-log of that 2, and that will become 100. Right? Now you can find the AC. What is the AC? AD by 100. Easily you can solve. What is the AD here? 100. 100 upon 100, that will become 1. 100 upon 100, that will become 1. Okay? Then Sandeep, first, because that question, in first question RS is not given, so I have just assumed the RS. You can make what? Fifth option for that. That is what 1 kilo ohm. Because RS is missing in this question. Consider a Zener diode shunt regulator. The input voltage maximum allowable is given. Then the minimum value of the load resistance. Okay. हाँ एक और है. Okay. You can find the value of RS also. How? If you have, first of all solve this. I will give you the another formula for that. If V1 is 0.6 volt, V2 is 0.4 volt, then yes, this one. ये हो गया AC. So what is the output here? Output is AD-VD plus AC-VC. AC-VC. What is the VD? V1 minus V2. V1 minus V2. And what is the VC? V1 plus V2 by 2. What is the V1 minus V2? 0.6 minus 0.4. That is 0.2. What is the V1 plus V2? 0.6 plus 0.4, 1 by 2, 0.5. That is the common value. So what is the V0? What is the AD? 100 into 0.2 plus 1 into 0.5. That will become 20 plus 0.5. That is 20.5. That is the answer for this question. 20.5. ये आ गया 20.5. B is the option for differential amplifier, and that will be the diagram. If it is not given, that is the standard diagram for this differential amplifier, just block diagram. This is called non-inverting voltage, inverting voltage, 0.6 volt, 0.4 volt it is given, and directly you can find the AC, and then you can use this formula AD-VD plus AC-VC. Okay. In first question, if you have asked doubt, then second important thing, if suppose you want to find the what is the IZ minimum I have given. So what is the formula for IZ maximum from the diagram? If you want to find the IZ maximum, then that right. If you want to find the IZ maximum, then in this formula, okay. यस देखो अब देखो IZ आया IZ maximum is given sorry already I have given the formula for the IZ minimum. right? Now Iz maximum, Iz maximum is equal to I maximum plus IL minimum. Okay, Iz maximum, I maximum minus IL minimum. Now from this formula you can find I maximum. What is the I maximum? Now try to understand. You can find the I maximum Vi max minus what? Vz. Vz is the output voltage upon Rs minus IL minimum. What is the IL minimum? If suppose you take the ideal condition, so IL minimum may become what? 0. How it will become 0? RL tends to what? Infinite. Then IL maximum, IL minimum will become 0. Why? Because what is the IL minimum? V by RL. Right? V not by RL, or RL we are taking the infinite. Make it what? Open circuit. So it will become 0. Then what is the Iz maximum? In first part I have given you the idea that what is the Iz maximum. It is given in the question 0.1 ampere. 0.1 ampere. That is another way. Now what is the Vi max? What is the Vi max then? 0.1 is equal to Vi max means Vi max is 25. And then what is the Vz? Vz is given as 5. What is the Rs here? If there is another way, so what is the Rs will become 25 minus 5, 20 divided by 0.1. That is 200. Now tell me, what is this Rs 200? Because 0.1 is in ampere. Remember, this is in ampere. That's why that will be in ohm. That will be in ohm. If you are using this data, then you have to use what? 200 ohm. Okay. In first case, I have given if Rs is given as 1 kilo ohm. If it is not given, then Rs you have to take it what? 200 ohm. And remember, this current, this is the formula. Always remember that should be greater than or equal to reading means Rs should be. तो आपको कैसे पता करना है अगर inequality में आ रहा है तो that should be, this current should be greater than or equal to or Rs should be value. Okay. Now it should be greater than or equal to 200 ohm. तो अब Rs आ गया. अब अगर इस फॉर्मूले को यूज कर रहे हो Rs को in there, then in this case Iz minimum is equal to I minimum minus I maximum. It should be greater than or equal to Izk. What is the I minimum? Vi minimum minus Vz upon Rs. I maximum Vz upon RL. That should be greater than or equal to 0 under ideal condition. So what is the Vi minimum? 10. That is given in the question 10. What is the Vz? 5. What is the Rs? Now it is 200. 5. RL minimum should be greater than or equal to 0. This is the 5 cancel out and you will get the RL minimum is equal to what? 200 ohm in that case. So it is a good doubt. If Rs is not given in the question, then in this way we can solve this question. If Rs is given as 1 kilo ohm, directly you can solve like this. That is the first approach. I think now it is clear to you. Right, in this question Rs is given as 1 kilo ohm. First part. If it is not given, then you can choose 200 ohm and you can get this answer. Okay. I think your doubt is clear, Sandeep. In that case, what will be the option? 200 ohm. See. Then next one is, this one is the differential amplifier. It is over. Third question. ये हमने अभी बनाया just. Calculate the output voltage. Already we have calculated now. The circuit shown in the figure, the collector current beta is 100. हो सकता है easy आए, बहुत ही ज्यादा क्वेश्चन, लेकिन आपको कैलकुलेशन मिस्टेक नहीं करना है. Collector current beta. Where is the collector current? IC. Right. अब थोड़ा सा आपको ये भी चेक करना है कि बस भाई सैचुरेशन में ना पहुंच जाए. तो कलेक्टर करंट इज IC और 1 किलो ओम RC is given. This voltage, if nothing is given, normally we are taking that as a silicon. what will be the IC? IC is equal to beta times of IB. And what is the IB? VBB minus 0.7 upon 100. So you can say 100 into 2 minus 0.7 upon 100. This 100 cancel, and what is the answer? 1.3 milliampere. 1.3 milliampere. But you have to verify it. You have to verify it. What is the value of the VCE then? It should be greater than or equal to VCE set. It should be greater than what? VCE set if it is in active region. That is the 0.2 volt. So definitely it is a 1.3. So what is the drop here? 1.3. 10 minus 1.3. It is 8.7. So yes, it is not in saturation. It is in active region. So what is the answer for this question? 1.3 milliampere directly you can put. So within 20 seconds you can solve this. So this type of questions we may expect. Okay, in BARC 2024. I think now it is also clear. That is the question. Now, third one. Fourth question. For the circuit shown, assume beta is 300. The collector power dissipation is. What is the collector power dissipation? When we are talking about the collector power dissipation, then what is asked here actually? Beta is given as 300. That is a very high value. And then this is the very, very high value RB. It is also 1 mega ohm. 1 mega ohm means 1000 kilo ohm, remember. And this is 0.7. Beta is given. So normally the power dissipation means, what is the power dissipation across the transistor? VCE into IC. VCE into what? IC. That is called the power dissipation. So first of all, quickly find the value of IC. That is equal to beta IB. Beta times of IB. What is the beta? 300. What is the IB? 10 minus 0.7. That is the 9.3. 10 minus 7.7 upon 1000. Right? This is in milliampere. Now this is cancel out. Okay. And then 3 into 0.93. That is the value of the IC in milliampere. Now, what is the value of VCE? Value of VCE will become VCC minus drop across that IC into RC. VCC minus IC into RC. It is the 10 minus this value into 2 kilo ohm. 3 into 0.93 into 2. Means definitely it is greater than what? 0.2. It means it is not in saturation. It is not in saturation. Now multiply it. What is the value of VCE and what is the value of IC, and give me the answer. Which answer is correct? Quickly calculate it. बनाओ भाई, क्या होगा जल्दी से बताइए जरा. थोड़ा आप लोग भी एफर्ट लगाइए इसमें. बिना कैलकुलेटर बनाने की कोशिश करो. ऑप्शन में बहुत गैप है. 4.42 milliwatt, 12 because the current is in milliampere, that's why you will get the answer in milliwatt. बोलो जरा. एक अप्रोक्सीमेट आंसर भी निकाल लोगे तो भी हो जाएगा. क्या आ रहा भाई संदीप और अदर स्टूडेंट्स कौन कौन है, जरा कमेंट्स कीजिएगा. व्हाट इज द आंसर फॉर दिस क्वेश्चन? इजी है ना, इतना तो कैलकुलेशन कर ही लोगे. बी फॉर बॉम्बे, यस 12.3 मिलीवॉट इज द आंसर. 12.3 मिलीवॉट. तो आपको आईबी निकालना है, लेकिन आईबी निकालने के लिए अलग स्टेप मत लिखिए, डायरेक्टली आईसी निकाल लो. बीटा आईबी कैलकुलेशन थोड़ा लास्ट में करिएगा एट द एंड, और दैट विल बी द कैलकुलेशन. यहाँ से सब्ट्रैक्ट कीजिए. इट इज नॉट इन सैचुरेशन रीजन एंड डायरेक्टली यू कैन सॉल्व. यस अकबर, योर आंसर इज ऑल्सो करेक्ट. तो दिस टाइप ऑफ क्वेश्चंस. देन नेक्स्ट क्वेश्चन देखिएगा जरा. दैट इज अगेन ऑन ऑपरेशनल एम्पलीफायर. फिगर shows an op amp circuit with voltage series feedback. So it is given, yes, voltage series feedback. Here input is given to non-inverting terminal and feedback is given to inverting terminal. Means it is a non-inverting operational amplifier because input is given to non-inverting terminal. 198 kilo ohm, 2 kilo ohm it is given. This is the value of RF. This is the value of R1. R1. The internal gain of the op amp is 5 into 10 to the power 4. इंटरनल गेन, मतलब ये आइडियल नहीं है, दिस इज नॉट एन आइडियल ऑपरेशनल एम्पलीफायर। इसका गेन दिया हुआ है 5 into 10 to the power 4, नॉट इनफाइनाइट। एंड इनपुट इम्पीडेंस इज 100 किलो ओम, द गेन ऑफ द एम्पलीफायर विद फीडबैक इज, अब बताओ भाई, इट इज एग्जाम्पल ऑफ वोल्टेज सीरीज फीडबैक। तो क्वेश्चन लंबा लगेगा बट इट इज अ वेरी वेरी इजी क्वेश्चन। यू हैव टू यूज in voltage series feedback, what is the formula? AV upon 1 plus beta AV. AV upon 1 plus beta AV. And what is the beta? R1 upon R1 plus RF. And this is R1 and that is RF. किसी को डाउट है तो ये डायग्राम ध्यान रखना। नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर, नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर, दिस इज RF, this is RF, this is R1 and that is VS is given here। उसको पूरा सीधा कर दो, राइट। तो ये RF आपको 198 दिखाई दे रहा है, 2 किलो ओम, रुक जाइए, 198 2 किलो ओम, एंड दैट्स व्हाई द बीटा इज इक्वल टू R1 upon R1 plus RF। तो 2 upon 2 plus 198 means 2 upon 200 means 1 upon 100। That is the value of beta. Now what will be the gain, and what is the gain here? 5 into 10 to the power 4. So it will become AVF with feedback AV, 5 into 10 to the power 4 upon 1 plus beta AV, 5 into 10 to the power 4 into 1 by 100. Then it will become 5 into 10 to the power 4 and this will become 1 plus 500. You can neglect the 500 1 near to that and it is become this is cancel out, this is cancel out, nearly equal to what? What is the answer? Which answer? और अगर एग्जैक्ट निकालोगे तो क्या आएगा यार? आंसर में ना ज्यादा गैप नहीं है, 99 110 50 100। now tell me which answer is correct, which answer is correct? देखो वैसे नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर का गेन होता है 1 प्लस RF बाई R1। अब 1 प्लस RF बाई R1 करोगे तो 198 डिवाइडेड बाई 2 प्लस 1, तो एग्जैक्ट आना चाहिए 100, 1 प्लस RF बाई R1। लेकिन आप जब उसकी वैल्यू दी हुई है, इट इज नॉट एन आइडियल ऑपरेशनल एम्पलीफायर, देन इट विल बी ऑलवेज लेस देन 100। तो विच आंसर इज करेक्ट? जस्ट आई हैव टेकन द अप्रोक्सीमेशन बट यू हैव टू यूज दिस वन। Why? Because it is very near to that। तो आपको चार ऑप्शन देखो ना, देखो 99 110 50 100, तो which answer is appropriate answer? ये हो गया आपका, ओके। तो यहां पर ये थोड़ा सा ध्यान रखना, ओके। अंडर एस्टिमेट, क्योंकि जो एक्चुअल रिजल्ट होता है वो अंडर एस्टिमेट होता है, तो ये है वैल्यू और ये है बीटा की वैल्यू R1 अपॉन R1 प्लस RF। नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर का सबसे जो मैक्सिमम गेन होता है 1 प्लस RF बाई R1, और अगर आइडियल कंडीशन लोगे, प्रैक्टिकल कंडीशन लोगे, दैट शुड बी लेस देन दैट, ओके। देन अब आते हैं दैट इनपुट इंपीडेंस इज ऑल्सो गिवन ना, तो एन इनपुट इंपीडेंस ऑफ 100 किलो, देन this is another question, this is another question. Figure shows an op-amp with voltage series feedback. The internal gain of op-amp is this one. Input resistance is 100 kilo ohm. Then input impedance of the amplifier with feedback is. तो देखो यहां पर ना वोल्टेज सीरीज फीडबैक लगा हुआ है, तो सब बताइए वोल्टेज सीरीज में इनपुट रेजिस्टेंस क्या होगा? इंक्रीज होगा और डिक्रीज होगा? What about the input resistance? It will increase or it will decrease. In a voltage series feedback, if you have idea, then easily you can solve this. Input resistance increases, so increases means RIF is equal to RI into 1 plus beta AV. So already RI, what is RI is given here? 100 kilo ohm. 1 plus what is the beta? 1 by 100, right? And into AV, 5 into 10 to the power 4. 5 into 10 to the power 4, it will become 100 into 500, nearly 501, right? And that will become 50100 kilo ohm. So what is this? Nearly equal to what? Nearly equal to 50 mega ohm. Nearly equal to 50 mega ohm. Yes, we can say Ri into 1 plus beta AV. Input resistance increases, and that is equal to, check my calculation. Check my calculation. ये हो गया आंसर, इंक्रीजेस. तो देखो इसका जो गेन है ना, फिर भी बहुत इंटरनल गेन ऑफ ऑप एम्प, नाउ इट इज वेरी वेरी हाई. इट इज गिवन 5 into 10 to the power 4. तो इसीलिए आपका आंसर ये होगा इंक्रीजेस. यस, राइट आंसर है. अब आते हैं जरा, ये देखो, दिस इज अ क्वेश्चन ऑन करंट मिरर सर्किट. कंप्यूट द W/L फॉर द Q1. What is the aspect ratio in the circuit if the output I0 is to be 6 milliampere? Consider the I reference is 1 milliampere. This is 1 milliampere and W/L for the Q2 is 12. बताओ भाई कितना होना चाहिए W/L? What will be? बहुत ही इजी क्वेश्चन है, बहुत ज्यादा इजी. ऐसे क्वेश्चन आएंगे सीधा सीधा रेशियो निकाल के बता रहा. दिस इज अ करंट मिरर सर्किट बाय यूजिंग द MOSFET. करंट मिरर सर्किट बाय यूजिंग MOSFET. देखो यहां पर ये दोनों करंट मिरर बना रहे हैं, दे आर फॉर्मिंग द करंट मिरर. और जो I0 एंड ये, दिस इज द Q1 एंड दैट इज द Q2. दिस इज द रेशियो ऑफ द Q1, दैट इज द रेशियो ऑफ द Q2. तो व्हाट इज द I0 अपॉन I रेफरेंस? I0 upon I reference is equal to W/L of 2 upon W/L of 1, because the current is directly proportional. What is the I0 is given 6, what is the I reference is given 1, what is the disk is given, you have to find the W/L of 1. That will become what? 2 here. तो कौन सा आंसर सही है? कोई ना कैलकुलेशन मिस्टेक करेगा हड़बड़ी में, इसका ये 6 ये दे देगा आंसर, बस सिली मिस्टेक के चांसेस है. तो यूज दिस फॉर्मूला एंड यू विल गेट द एग्जैक्ट वन. दिस इज द करंट मिरर सर्किट बाय यूजिंग MOSFET. ओके, स्ट्रेट फॉरवर्ड फॉर्मूला एंड यू कैन यूज इट. करंट मिरर सर्किट. नाउ नेक्स्ट वन, नेक्स्ट क्वेश्चन. Identify the given circuit of the figure. Okay, tell me what is the feedback mechanism in this? Identify the given circuit of the figure. Voltage shunt feedback, current shunt feedback, voltage series, current series. There are 4 feedback topology. 4 feedback topology or mechanism. Feedback mechanism. बताइए इनमें से कौन सा है? वोल्टेज शंट, और दिस इज अ, वी आर गेटिंग द आउटपुट फ्रॉम कलेक्टर. इट इज अ एमीटर, आर इज कनेक्टेड, आर एस मीन्स इट इज अ, अब चलो आपको हिंट दे देता हूं, इट इज अ कॉमन एमीटर विद अनबाईपास्ड आर ई. कॉमन एमीटर विद अनबाईपास्ड आर ई. Unbypassed RE. If we are connecting a capacitor here, then it is called bypassed RE. Then there is no feedback, but there is no capacitor. There is no capacitor. So unbypassed RE, and we are getting the output from the collector. तो आंसर 99 अकबर अली. हाँ अकबर, देखो हाँ वहां पर जो पहला जो क्वेश्चन पूछ रहे हो ना, अंडर आइडियल कंडीशन इट इज नो डाउट 100. Under ideal condition 1 plus Rf by R1 it is nearly equal to what? 100. No doubt when we are getting between what? 99 and 100, then what is the best approximation? Best approximation means we have to consider the effect of the input resistance. What was the input resistance? That is also not infinite. तो उस केस में क्या होगा? आपको आंसर लेना पड़ेगा जो उससे कम है. तो कौन है उससे कम? 99. Are you getting my point? कोई कंफ्यूजन नहीं है. आप बोलोगे सर 99.8 आया था तो मैं क्या लूं? what is not the approximation, what is the best approximation? What is the best approximation in this case? In this case, okay, 50 is a very low value. We are getting 99.8 nearly equal to and we have not considered the effect of what input impedance. When we are considering the effect of the input impedance, then definitely again that current will volt gain will reduce, and that's why answer is what 99. I think it is clear to you. क्योंकि देखो अंडर आइडियल कंडीशन व्हाट इज द गेन 1 प्लस आर एफ बाई आर वन. 1 plus RF by R1 is what? 1 plus 198 RF by 2. 198 by 2. That is the 1 plus 99. So what is the exact answer? 100. तो इसी से बना लेते फिर तो ये आ जाता है. ये अप्रोक्सीमेटेड आंसर है. दिस इज अप्रोक्सीमेटेड आंसर. तो बेस्ट अप्रोक्सीमेशन इज लेस देन दैट अंडर प्रैक्टिकल कंडीशन. चलो बताओ भाई फीडबैक मैकेनिज्म. रिमेंबर गाइस देयर आर 4 फीडबैक मैकेनिज्म. Voltage series, voltage shunt, current series, current shunt, and that is the example of what current series feedback. Common emitter with unbypassed RE. That is the example of what current series feedback. यहाँ पर आउटपुट में भी आप करंट सैंपल करते हो, इनपुट में आप वोल्टेज मिक्स करते हो, और दोनों साइड सीरीज कनेक्शन है. दैट्स व्हाई द इनपुट रेजिस्टेंस इंक्रीजेस, आउटपुट रेजिस्टेंस बोथ इंक्रीजेस बिकॉज ऑफ दिस फीडबैक. इनपुट रेजिस्टेंस आफ्टर फीडबैक इंक्रीजेस, आउटपुट रेजिस्टेंस आफ्टर फीडबैक इंक्रीजेस. तो याद रखिए व्हाट आर द एग्जांपल ऑफ वोल्टेज शंट, व्हाट आर द एग्जांपल ऑफ वोल्टेज सीरीज, व्हाट आर द एग्जांपल ऑफ करंट शंट, एंड व्हाट इज द एग्जांपल ऑफ करंट सीरीज फीडबैक. तो कॉमन एमिटर विद अनबाईपास्ड आरई. ये तो 10 सेकंड में बनेगा अगर आपको पता है. अदरवाइज वॉच माई लेक्चर ऑन फीडबैक. देखो नाउ ऑप एम्प हैज अ स्ल्यू रेट ऑफ 15 वोल्ट पर माइक्रोसेकंड. द पावर बैंडविड्थ फॉर अ पीक आउटपुट वोल्टेज ऑफ 10 वोल्ट. देखो पीक आउटपुट वोल्टेज दिया हुआ है 10 वोल्ट. पावर बैंडविड्थ फॉर अ पीक आउटपुट वोल्टेज ऑफ 10 वोल्ट. सर बार के एडमिट कार्ड में, अच्छा विनय मैंने देखा नहीं. विनय आई विल कलेक्ट द इंफॉर्मेशन एंड देन इन्फॉर्म यू. ओके. तो अगर लिखा है ड्यूरेशन 160 मिनट, क्या लिखा है और भी कुछ डिटेल दिया हुआ है. ये चेंज होते रहता है इनका पैटर्न. दे कैन चेंज पैटर्न. ओके. कुछ भी आपका पिछला पेपर होता नहीं अवेलेबल, कुछ भी हो सकता है, तो आपको तैयार रहिए मेंटली उसके लिए. तो ऑप एम्प हैज अ स्ल्यू रेट. अब देखो स्ल्यू रेट क्या है? मैक्सिमम रेट ऑफ चेंज ऑफ आउटपुट वोल्टेज. मैक्सिमम रेट ऑफ चेंज ऑफ आउटपुट वोल्टेज. फिर ये आता है ACL इंटू मैक्सिमम रेट ऑफ चेंज ऑफ इनपुट वोल्टेज. राइट, मैक्सिमम. और अगर आप देखें कि ये साइनोसॉइडल सिग्नल है Vm साइन ऑफ ओमेगा टी, तो इसकी जो रेट हो जाती है वो है Vm ओमेगा cos ओमेगा टी. When it will be maximum, when it is 1. What is the dVi by dt maximum? dVi by dt max will become Vm omega m. Vm omega m, and when the cos omega t will become 1. Vm is called maximum frequency of operation or bandwidth. तो यहां पर किसमें चाहिए? हर्ट्स में चाहिए, and that is in radian per second. Right? तो ओके, मैं इसको रीड करके भी नहीं बताता हूं मैं आपको. तो Vm omega m, तो आप यहां पर यूज करोगे तो slew rate is equal to what? Closed loop gain into what? Vm omega m. What is the omega m? Omega m is nothing but 2 pi fm. Will become slew rate divided by closed loop gain into Vm. Vm is the maximum amplitude. Now what is asked here? Slew rate is given 15 volt. The power bandwidth for a peak output voltage of 10 volt. अब आप बोलोगे सर क्लोज लूप गेन तो दिया ही नहीं है. तो क्लोज लूप अगर गेन नहीं दिया हुआ ना, तो सबसे ज्यादा बैंडविड्थ कब मिलेगी? व्हेन द गेन इज द लोवेस्ट, दैट इज 1 in case of voltage follower. In case of voltage follower, suppose we are using this, so what is the FM? FM will become slew rate. What is the slew rate? 15 volt into 10 to the power 6 volt per second. First of all, convert it into volt per second, because it is given is volt per microsecond. ACL, if it is not given, you can take 10 into 2 pi, because it is asked in hertz. Then it will become, चलो कैलकुलेशन कर लो यार थोड़ा कैलकुलेटर. तो ऐसे आप एक रफली कैलकुलेशन कीजिए. 15 डिवाइडेड बाई 2, दैट इज द 7.5 डिवाइडेड बाई पाई, 22 बाई 7. इंटू 10 to the power 5। इतना तो कर लोगे आप कैलकुलेट, बताओ जरा कितना आएगा। आ 2.38 इंटू 10 to the power 5, अगर मैं इसको 100 से मल्टीप्लाई कर दूं तो 238 के आसपास क्या आ रहा है भाई। हाँ देखिए 238.63 मीन्स विच आंसर इज करेक्ट, 239 नियरली इक्वल टू 239 किलो हर्ट्ज, नियरली इक्वल टू 239। आर यू गेटिंग माय पॉइंट। स्लीव रेट, तो देखो स्लीव रेट इज इंपॉर्टेंट टॉपिक ना, इजिली यू कैन सॉल्व। The op-amp has a slew rate of that, power bandwidth for the peak voltage, and then what is that? That's already I have given you the complete formula. Yes, 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 Vinay. Yeah, again answer 239 kilohertz. 239 kilohertz. That will be in hertz. ये formula है, ये देखिए. That is the formula for FM bandwidth, maximum frequency of operation. अब देखिए, in an amplifier with a gain of 1000 without feedback and cutoff frequencies at 2 kilohertz and 20 kilohertz, negative feedback of 1% is employed. Negative feedback, देखो without feedback जो आपका gain है ना, ये, तो what is the without feedback? The gain is 1000 और lower cutoff frequency is 2 kilohertz and upper cutoff frequency is 20 kilohertz. Then if the feedback of 1% is employed, the cutoff frequency with feedback would be, what will be the cutoff frequency? तो cutoff frequency निकालने के लिए आप ध्यान रखिएगा एक डायग्राम जो है, what are the advantages of the negative feedback? What about the bandwidth, increases or decreases? When we are calculating, that is the case. This is the FL, without feedback this is the FL and FH, higher cutoff frequency, lower cutoff frequency, and that is called mid band gain, that is given as 1000. But when we are using the feedback, then what will happen, the gain will reduce, okay, FL will reduce, FLF, this is the with feedback, and FH will increase. What about the overall bandwidth? After feedback, the overall bandwidth will increase. Overall bandwidth will increase. And what about the gain? This is the new mid-band gain, that is called gain with feedback. So that is the case. So what is the disadvantage? The gain will reduce, but what about the advantage? Lower cutoff frequency will reduce, upper cutoff frequency will increase, and overall bandwidth will increase, and that's why the stability of the system increases. Now, what is asked here? The cutoff frequencies with feedback would be, okay. अब देखो cutoff frequency जो FLF है ना, that is will be less than FL. So what is the FL here? 2 kilohertz. So which one is the less than 2 kilohertz? So this is all are less than that 2 kilohertz. And all are greater than, and the higher cutoff frequency will be greater than what? 20 kilohertz. So this is higher, this is higher, this is higher, this is higher. So yes, what is the formula then? Then FLF is equal to FL divided by 1 plus beta AV. And what is the FHF? FHF will become 1 plus beta AV into FH without feedback. It will decrease, that will increase. What is the beta here? 1%. 1% means 0.01. 1% is 0.01, and that's why 1 plus beta AV. 1 plus, what is the beta? 0.01 into 1000 gain. So it will become 10 plus 11. It is 11. That is called desensitivity factor. 1 plus beta AV is 11, desensitivity factor. And that's why this will become 200, sorry, what is the FL initially? 2 kilohertz. So 2000 divided by 11. That will give you the answer. 2 kilohertz means 2000 hertz divided by 11. Now calculate. and FHF will become 11 into old FHF. What is the old FHF without feedback? 20. So 20 kilohertz. It will become 0.22 and that will become 220 kilohertz. And 2000 divided by 11 तो means 1 point, sorry 1 point नहीं और 90 आ गया 18 ना 88 और फिर आ गया 2 मतलब 181 समथिंग. ठीक है, 2000 को 11 से डिवाइड करो कितना आ रहा है और बताओ जरा. 180 समथिंग आएगा. तो देखो यहां पर आ गया 220 kilohertz higher cutoff frequency and 1 nearly equal to 182 lower cutoff frequency. So tell me which answer is correct. हाँ अकबर, कौन सा आंसर सही है? I think B is the correct one. B is the correct answer. So always remember lower cutoff frequency will reduce by factor 1 plus beta AV, higher cutoff frequency will increase by factor 1 plus beta AV. 182 and 220 kilohertz is the answer for this question. और ये है पूरा डायग्राम आपके सामने. That is the complete advantage and disadvantage of negative feedback. Bandwidth will increase. Then अब बताओ जरा. If emitter bypass capacitor in common emitter amplifier is removed, then अभी आपको मैंने हिंट किया था. If the emitter bypass capacitor in common emitter bypass capacitor means this is the diagram. This RE is connected here. This is RC. This is the VCC. And normally we are having this type of diagram. This is the potential divider circuit. We are taking output from this. We are giving input to this. This is called common emitter. Now here one capacitor is connected, that is called bypass capacitor. When this is the bypassed RE, there is no feedback. There is no negative feedback because RE is bypassed. It will act as short circuit. So what about the voltage gain? Very, very high. But when we are removing this, just remove the bypass capacitor. Now in the circuit RE is present because of this negative feedback is present. Voltage gain will reduce. Voltage gain will reduce. But what is asked here? What about the input resistance? Voltage gain. Voltage gain will decrease. So this is the voltage gain will decrease. Finished. तो अब यहाँ पर लिखा है what about the input resistance? तो भाई ये तो सही हो गया ना, voltage gain will decrease because of the negative feedback. But what about the input resistance? Because already we have solved one question. The feedback mechanism is current series feedback. Once that is C is removed, the feedback mechanism is current series. Or in this current series feedback, input resistance increases. Input resistance increases. And that's why this statement is wrong. Voltage gain will increase. That is wrong. Voltage gain will remain unaffected. That is wrong. तो ये हो गया आपका सीधा सीधा आंसर. C is the correct answer. Voltage gain will reduce, input resistance will increase, not decrease. Output resistance will also increase. Okay. अब बताओ जरा, ये तो पता है एमीटर फॉलोअर. अरे एमीटर फॉलोअर पे तो अभी क्वेश्चन बना लिया हमने. Current gain is always less than 1. Voltage gain is always less than 1. Very small input impedance, very large output impedance. Which answer is correct? Emitter follower. They are not going to give you the diagram. Directly आपको आंसर बताना है. बताओ क्या होगा? What will be the answer for this question? Okay, बताओ जरा. रैपिड फायर राउंड है भाई. आपको टॉपिक याद करना है. कितना हुआ जल्दी से बताइए जरा. बताए एमीटर फॉलोअर. करेंट गेन इज ऑलवेज लेस देन 1. अब करेंट गेन तो है ही नहीं वहां. वोल्टेज गेन दैट इज ऑलवेज लेस देन 1. यस, वोल्टेज गेन इज लेस देन इक्वल टू 1, नियरली इक्वल टू. बी इज द करेक्ट आंसर. वेरी स्मॉल इनपुट इंपीडेंस very high input impedance, because in this the feedback mechanism is voltage series feedback. Input resistance is very high, output resistance is very low. This is wrong, this is wrong, this is correct. Okay, that is the B is the correct answer. Yes, Akbar, your answer is correct. Remember, the feedback mechanism is voltage series feedback, right? तो ऐसे क्वेश्चंस आएंगे. ओके, अब आते हैं जरा, आपको ये बता दूं, ये शेड्यूल है फॉर बार्क 2024 and 25 इलेक्ट्रिकल इलेक्ट्रॉनिक्स. Already we have taken the control, communication, digital electronics, network on 1st March. You can also see the lecture. Already I have discussed very important. On 4th March, signal and system done. Analog circuit is running, and on 8th of March, EMFT, electromagnetic field theory at 6 PM. Please note the time. Okay, तो यहाँ पर जो एनालॉग है ना, ये अभी आज क्वेश्चन डिस्कस हो रहे हैं. दैट इज द शेड्यूल. अब आते हैं जरा नेक्स्ट क्वेश्चन पर. आप बताते जाइएगा क्या क्या आंसर है. BJT Darlington pair has. For Darlington pair, tell me which answer is correct. High input impedance and high beta, high input impedance and low beta, low input impedance and high beta, low input impedance and low beta. Which answer is correct? Darlington pair. What is Darlington pair? Common collector followed by common collector. That is called Darlington pair. We are getting the output from this. This is called Darlington pair. Common collector followed by common collector. So for common collector, current gain is very high, and again when we are connecting to, the current gain will become very high. Beta, effective beta is very high. 1 plus HFE the whole square. This is called effective beta. And the input impedance is also very high. 1 plus HFE square times of RE. 1 plus HFE square times of RE. So input resistance is very high, and that's why, and beta is also very high. That's why it's called super beta transistor. What is the name? Super beta transistor. चलो भाई, अब आप इतना आपको आंसर देना है फास्ट. रीड करो, क्वेश्चन का जवाब बताइए. तो ट्रांजिस्टर एम्पलीफायर विद 85% ऑफ एफिशिएंसी इज लाइकली टू बी. कौन सा होना चाहिए? ट्रांजिस्टर एम्पलीफायर with 85% of the efficiency. What is the efficiency? Means power conversion efficiency. So there are different types of operation: class A, class B, class AB, class C, right? So it is nearly equal to 25% B, 78.5% AB, nearly equal to 60%, which will give you the 85% power conversion efficiency. So when we are moving, class A efficiency is very low, right? 25% in case of direct coupled, and around 50% ideal condition for transformer coupled. Class B ideal efficiency is 78.5%, right? Class AB is less than the efficiency of class B, and the class C nearly equal to 90%. Means if you want 85% of efficiency, that is the class C. That is the class C. So everyone please revise the power amplifier. Then tell me, in a class AB amplifier, the current flows through the active device for less than half of the duration of the input cycle, half duration of the input cycle, more than the half but less than the full cycle duration, full duration of the input cycle. क्या होगा भाई? क्लास AB, क्लास AB. चलिए मैं आपको बता देता हूं, क्लास ए बी में कितना आएगा बताओ जल्दी से. चलिए रीड करो, क्वेश्चन बताओ. क्लास ए बी एम्पलीफायर, द करंट फ्लो थ्रू द एक्टिव डिवाइस फॉर, देखो क्लास ए के लिए पूरे साइकिल के लिए फ्लो करता है 360 डिग्री के लिए. फॉर क्लास बी 180 डिग्री, मीन्स फॉर हाफ साइकिल. Class C less than 180 degree, means less than half cycle, or class AB greater than half cycle but less than the full cycle. So that's why what is the conduction angle? 180 is less than phi is less than what? 360 degree, or nearly equal to what? 180 degree, but more than 180. This is the 360. So class AB, more than half but less than the full cycle duration. More than half but less than the full. The active device for more than half but less than the full cycle duration. ये सब आंसर आप पावर एम्पलीफायर्स के बारे में पता कर लीजिए, राइट? ये सब क्वेश्चंस आपके आएंगे. ओके, चलिए एक लास्ट क्वेश्चन बताइए जरा. विच ऑफ द फॉलोइंग एम्पलीफायर सफर्स मेनली फ्रॉम द प्रॉब्लम ऑफ क्रॉस ओवर डिस्टॉर्शन? क्या होगा भाई अकबर, विजय, विनय, किसमें क्रॉस ओवर डिस्टॉर्शन होता है? Which of the following amplifier class suffers mainly from the problem of crossover distortion? तो देखो, crossover distortion जो है, that is the problem when we are dealing with the class A, there is no distortion but the efficiency is very very low, and that's why I enter into the class B where the efficiency is very very high, but it suffers from the crossover distortion. And just to remove the crossover distortion, we are using the class AB. We are just using the class AB. There is no crossover distortion. The answer for this question is, which class suffers from the crossover distortion? That is the class B. That is the answer. That is the answer for this question, guys. Okay. तो ये है आपके, इस तरीके से आपसे क्वेश्चंस आएंगे, आपको ध्यान रखना है. गाइज हम लोग ले रहे हैं ग्राउंड जीरो सीरीज for electrical, electronics, civil, mechanical and computer science branch. This is already live on app, but you have to install the Byjus exam prep app, right? And then this is a ground zero series for GATE 2025. Already we have taken one session for strategy, so you can also watch what should be the proper strategy for GATE 2025. And we are also going to start one series on YouTube also, but this is the series on app. So first of all, install Byjus exam prep app now. Okay, अब चलिए जरा, चलिए इसका आंसर बताइए. The ripple factor for a half wave rectifier is, what is the ripple factor for half wave rectifier? Standard circuit for half wave rectifier. ये तो इजी है भाई. What is the ripple factor for half wave rectifier? 1.65, 1.451, 1.21. तो देखिए, ripple factor means RMS value of the AC component, RMS value of the AC component upon DC, right? An AC component is called ripple. So this is the RMS value of the AC component upon DC. Then ripple factor for half wave rectifier is what? 1.21. Then what is the ripple factor for full wave rectifier? Give me the answer, everyone. Tell me what will be the answer, right? So this is the answer, 1.21 for half wave rectifier. Then a clamper. What is the clamper circuit? There are two statements. Which of the following statement are correct? Clamper circuit adds or subtract a DC voltage to or from a waveform. To or from a waveform. Clamper क्या करता है? DC voltage को add कर रहा है एक waveform में. Add करता है या subtract करता है? क्या ऐसा करता है? Does not change the shape of the waveform. Does not change the shape of the waveform. Yes, it will add DC or subtract. If it will add, it is called positive clamper. It will subtract, then it is called negative clamper. And it will not change the shape of the waveform. Means if it is a right, if it is a what? Sinusoidal, it will remain sinusoidal. Triangular, it will remain triangular, and so on. तो मानसी आप क्या पूछ रहे हैं? बार का कट ऑफ कितना रहता है? प्रीवियस देख सकते हो, लेकिन एक बात बताएं, अभी तो आप एक बार कोशिश कीजिए, ट्राई टू सॉल्व एज मैक्सिमम एज पॉसिबल, एंड इन एग्जाम यू हैव टू डिसाइड क्या, हाउ मेनी कैंडिडेट्स आर देयर, व्हाट इज द लेवल, व्हाट विल बी द लेवल ऑफ द क्वेश्चन पेपर, डिपेंड्स अपॉन नंबर ऑफ टॉपिक्स. ओके, सी बोथ 1 and 2. सॉरी ये प्रिंटिंग मिस्टेक है, बोथ 1 and 2. दिस इज द क्लैम्पर सर्किट. अच्छा भाई, अब देखो ये वाला है ना, ऐसा क्वेश्चन गेट में भी आया था ऑलरेडी, मैंने बहुत सारी क्लासेस में डिस्कस किया है. बताओ जरा. द ऑसिलेटर सर्किट shown in the figure has an ideal inverting amplifier. Its frequency of oscillation is. What is the frequency of oscillation for this? ये इस साल गेट में भी क्वेश्चन था, ये इस साल गेट का भी क्वेश्चन था. बोलो जरा. तो ना इसको बनाना नहीं है, जैसे गेट एग्जाम में आप क्या कर रहे थे, बना रहे थे, वहां भी बनाना नहीं था इसको. आपका स्टैंडर्ड सर्किट है और ये आरसी आरसी आरसी. हाँ, गेट में जो क्वेश्चन था ना उसमें क्या किया था, उसने एक हाई पास फिल्टर और एक लो पास फिल्टर लगाया था. दैट वाज द फीडबैक. वन वाज द हाई पास, वन वाज द लो पास in the feedback. But here it is a RC phase shift oscillator. For RC phase shift oscillator, what is the frequency of oscillation? It is just any amplifier. It is an inverting amplifier, right? It may be what? It may be FET or it may be operational amplifier, right? It is given now. Oscillator circuit shown in the figure is an ideal inverting amplifier. Its frequency of oscillation in hertz. So for RC phase shift oscillator, the frequency of oscillation is 1/2 pi RC root 6. तो देखो कितना टाइम लग रहा है आंसर देने में, सीधा स्ट्रेट फॉरवर्ड लगाना है आंसर. ये 1/2 pi RC root 6. तो ये ध्यान रखिए, ऑसिलेटर के पूरे फॉर्मूले रिवाइज कर लीजिए आप लोग एक बार. विन ब्रिज ऑसिलेटर, विन मल्टीवाइब्रेटर बाय यूजिंग एंड सो ऑन. ओके, होप आपको बात समझ में आ गई होगी. तो वी आर टेकिंग व्हाट one important session for you, post gate session on app, right? तो हाँ आपको पता चलेगा all about the COAP, cut off chronicles for IIT Madras, Delhi, Mumbai, Guwahati, Roorkee and so on, all about the CCMT, right? IITs through low gate score, NITs through low gate score. अगर आपको जो भी डिटेल चाहिए, you can install the Byjus exam prep and you can join and you can ask your doubts also, right? But that these are the sessions on app. ओके, इंस्टॉल करना होगा आपको. अब चलिए जरा इस क्वेश्चन का आंसर बताओ. द फिगर गिवन बिलो शोज द ट्रांसफर कैरेक्टरिस्टिक्स ऑफ विच वन ऑफ द फॉलोइंग. क्या ये क्लीपर से रिलेटेड है या क्लैंपर से, जल्दी से बताइए जरा. क्लीपर और क्लैंपर किससे रिलेटेड है? It is related to. क्या होगा आंसर भाई? बोलो भाई. A, it is a peak clipper, bottom clipper, two level clipper. It is a peak clipper. Yes, Siva, you have given the right answer. And Akbar, your answer is correct. It is a peak clipper. जब ऊपर के पोर्शन को जब हम लोग कट करते हैं ना, देखो एक रेफरेंस लेवल, अबव वन रेफरेंस लेवल देयर इज अ कांस्टेंट लेवल, मींस इट विल कट. दिस इज द लाइन एक्चुअली, बट हियर इट विल नॉट फॉलो द इनपुट. आउटपुट इज कांस्टेंट. That's why it is a peak clipper, or this is also called positive clipper. This is also called positive clipper. तो आपको अब टॉपिक समझ में आ गए होंगे कि कौन कौन से इंपॉर्टेंट है. पूरे जितने भी फिल्टर्स है ना वो जरूर देख लेना. All the active filters, standard diagram, right? For example, the op-amp circuit shown below represent a high pass filter, low pass filter, band pass filter, band reject filter. So get the idea about the high pass, low pass, band reject, all pass. What are the angle for all pass filter and so on. तो जैसे ये है, अब देखो यहां पर अगर इस पाथ पे C है on the feedback, then it is a integrator or it is a because of that low pass filter. यहाँ इंडक्टर है, then again it is a लो पास फिल्टर. तो व्हाट इज द आंसर फॉर दिस क्वेश्चन? जैसे हम लोग नॉर्मली बनाते हैं ना लो पास फिल्टर, इंटीग्रेटर इज अ लो पास फिल्टर. व्हाट वी आर जस्ट कनेक्टिंग अ कैपेसिटर, राइट. और अगर इधर इंडक्टर लगा दे, देन अगेन इट इज अ लो पास फिल्टर. अब यहां इंडक्टर है, यहां कैपेसिटर, तो अगेन इट इज अ लो पास फिल्टर. तो ऑल फिल्टर्स, मैंने जस्ट हिंट किया आपको, मेरे काफी सारे सेशन लिए हुए हैं, तो आप वहां से पूरा आप देख लीजिएगा और कैसे सॉल्व करना है. ओके, तो गाइस आज के लिए इतना ही. काफी मतलब मैंने आपको एक आइडिया दे दिया. एफईटी से भी क्वेश्चंस आ सकते हैं, करंट मिरर से भी क्वेश्चन आ सकते हैं, क्वेश्चंस ऑन फीडबैक, क्वेश्चंस फ्रॉम व्हाट ऑपरेशनल एम्पलीफायर, क्वेश्चंस फ्रॉम पावर एम्पलीफायर, मॉसफेट पर, बीजेटी पर, डायोड्स, सर्किट्स पर क्वेश्चंस आ सकते हैं. तो दैट इज यू कैन गिव द मॉक टेस्ट to download the Byjus exam prep. That is the leaderboard, number of students, what about your ranks, you will get the detail about this. And then we have started the course for what Vision Gate 2025 and 2026. So you can join with what live classes, recorded lecture, study material, practice quizzes, mock test, all facilities are here. And you can call at this number guys, right? 9241 333 666. And if you want to book your free counseling, GATE and ECE 2025-2026 to get the idea about the course, or if you have any doubt regarding what GATE and engineering services, then you can book your free counseling or simply fill the form for free counseling. तो आप कॉल कर सकते हैं या आप काउंसलिंग फॉर्म भी फिल कर सकते हैं. ठीक है, तो ये है काउंसलिंग फॉर्म दिया हुआ है डिस्क्रिप्शन बॉक्स पर. This is my Telegram channel. I will upload the PDF of this session. Go through those questions. Already I have solved straightforward questions. Standard answer. First of all, get the idea about the standard answer. अगर न्यूमेरिकल भी आ रहा है ना, तो स्टैंडर्ड जो आंसर है उस पर बेस्ड आएगा, तो क्विकली यू कैन सॉल्व इट. रेंज थोड़ा ध्यान रखो क्या आता है. ओके देन, थैंक यू वेरी मच फॉर अटेंडिंग द सेशन. Like the session, subscribe our channel and share the link of this session guys. Thank you and have a nice day.